Okay, dear students, Assalamu alaikum and welcome back to our class of biopharmaceutics. In this class, we will learn some basic concepts of the designing of the biopharmaceutical studies. Being a professional pharmacist and we can say just the product leader and the team leader and principal investigator, a pharmacist has a job to make a exact and the correct study design for the evaluation of the good results of the bioequivalence studies. And for this, we have already started this topic with the application of study design, and we have already told you there are some ideas where we have to check either the effect of food, the presence or the absence of food have the different effects on the bioavailability and the bioequivalence studies. Now today we will move towards the designing or the division of the individuals into different groups, and how we will check the variations within the subjects and also the some parameters which we have required to fulfill the conditions of statistical evaluation. So start with the crossover study design. As the word crossover means, subjects who meet the inclusion and exclusion study criteria and have given informed consent are selected at random. A complete crossover design is usually employed in which each subject receives the test drug product and the reference drug product. Crossover means each subject receives the test drug product and the reference product, and examples of the Latin scale crossover design for bioequivalence are given in the book, where we will have to use two brands. For example, we want to compare two or three or the four different brands. Then we will write some Latin scale crossover design, especially when we see the table 16.7. There are the three brands A, B and C, and we will have to make a sequence of the product. For example, we have the three drug products, and we will make the study period of 1, study period 2, then study period 3. Between the study period, we will have to give a washout period. I will explain all these. For example, we want to make this study on 6 subjects. Then these subjects will be provided. For example, subject 1, 2, 3, 4, 5, 6 and 7. In case of crossover studies, I have already told in my yesterday class, in case of crossover study where the half-life of the drug is small and we can make a washout period at least 10 half-lives and then reevaluate or the change the sequence of the individuals. In case of study period 1, for example, we have 3 brands A, B and C. One protocol should be brand. In case of study period 1, we can use these formulations, these 3 formulations with this sequence A, B, C, then B, C and A, then C, A and B, then C, B, A, C, and B, C, B, and A, and the sixth one is B, A, and C. As we have started this design by the sentence, each volunteer will receive test as well as the reference brand. The beauty of the crossover design is each volunteer will receive the whole all the brands, all the drugs, either they are the references or the test. For example, subject 1 in study period 1 will get A, and after washout period, after 10 half lives, at least 2 weeks, then he will receive B, and after the washout period of the 2 weeks, he or she will receive C. Same case with the individual subject B, subject 2 will get first B, then C, then A. Remember, there are a sequence. A brands are using by the 2, B brand is also treated with the individuals with the 2, and also the C is also having the being used with the 2 people, two volunteers. So the sequence means we will have to check what we are given to the subjects. In case of crossover design, each and every individual have the equal chance to use the each and every dosage form. For example, if we want to make a concept of the 3, the same way when we want to make a study between the 4 different brands and want to evaluate the bioavailability study or the bioequivalence of the 4 different brands, and they are written by A, B, C, and D. So we will have to use 16 individuals 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15, then 16. Okay, these are our volunteers, and among the volunteers we will have to make some variations to check the variations. Now we are working on the 4 brands, so it's period 1, then period 2, same case with period 3 and period 4. Period 3 and period 4. Now we have 4 brands. Start with the A, B, C, and D. Then B, C, D, and A. Then C, D, A, and B. Then D, A, B, and C. Then once again A, B, now change this, D and C, B, D, B, D, C, and A, then D, C, A, and B, then C, A, B, and D. Because of 8. Then A, now change this, C, B, and D, C, B, D, and A, then B, D, A, and C, D, A, C, and B. Once again, change the A and D, then start with the, for example, 13, start with the C, this one, start with C, C, D, A, and B, then D, A, B, and C, then A, B, C, A, B, and C and D. And then once again, uh, it's D, A, B, C, okay? A, B, C, and D, and B, A, C, and D. These are the basic sequence: B, A, C, and D, 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 B, A, and C, and at the top C, D, B, and A. Then D, A, C, and B. This is the sequence for the drugs where we want to compare the 4 different brands. What we are doing? We are applying the crossover study. And in case of crossover study, we will make a sequence of the brands, sequence of the use of the brands. For example, there are the 16 volunteers. In case of study where we want to make the 4 different brands. In 16 volunteers, we will make the some variations within the volunteers. For example, when we are studying the period 1 and volunteer 1 will receive brand A and volunteer 2 will receive the brand B. In case of volunteer 1 in the after washout period, he will receive brand B, and after washout period he will receive C and D. But the same sequence will not be repeated in whole volunteers. And when we count the total number of A and total number of B used by the single day, for example, A is here, 2, then 3, then there may be 4 A's. Okay, and same B, here is B, then B, here is B and B. And then C, and C. Then D, this one D1, D, and then D. There are the sequence of the different concepts. And same case in period 2, and then period 3, and then period 4. Why we are doing that the same? We will have to take the average of the results. When we are using we will get the data from the volunteer A. We will take the blood samples from volunteer A and volunteer 1 and giving the brand A. Then we will make a time versus concentration curve and calculate AUC by using the same A, this one, and then make the mean value, because our whole results will be applied on the mean value. Okay, come to the point. When we are using the crossover study, there are the Latin scale design plans, the clinical trials. This is basically concepts of the Latin scale, because in case of Latin scale design, we will have the variations. In case of period 1, we are using the A, B, C, D whole brands, but you are using the different volunteers. And same case when we move toward the period 2, we are using the same number of brands, but using the different volunteers, and the same study will be repeated. Okay. In case of Latin scale design, the subject to subject variations is reduced. Moreover, variations due to sequence, period, and treatment are reduced. Means there should be a difference, the variation between these sequences, periods, and the treatments will be reduced, and so that the patient don't receive the same drug products on the same day in the same order. The order in which the drug treatments are given should not stay the same in order to prevent any bias in the data due to the residual effect from any particular drug product are minimized by changing the sequence or order in which the drug products are given to the subject. Thus, the drug product B may be followed by the drug product A, D as shown in the table. After each subject received a drug product, blood samples were collected and appropriate time. And remember, the word appropriate time means the time in which we have Cmax and Tmax, because Cmax, Tmax, AUC. These are the three basic parameters which we use for the sake of calculations. Okay, in case of the time intervals should be spaced to the peak blood concentration, the total area under the curve, the absorption and the elimination phase of the curve may also be well described, and the word period refer to the time period in which the study is performed. A two-period studies basically and two period studies are basically the two-period study is a study that is performed on two different days, time period, separated by the washout period, which most of the drug is eliminated from the body, generally about 10 elimination half-lives. A sequence refers to the number of the different orders in which the treatment of the group is a study. For example, a two-sequence, two-period study would be designed as follows. Okay, in case of two period, a sequence refers to the number of the different orders in the treatment group in a study. For example, two period study would be designed. For example, the sequence means that this is actually a sequence in which we are giving the sequence is usual one get one A, then B, then C, then D. This is sequence. And this is actually a period. Period and sequence should be altered, because in case of period, by changing the period, we are reducing the variations within the subject and also the between the periods and the sequences. Okay, design for the narrow therapeutic say replicated crossover study design. It's another is the type of the crossover design is replicated crossover design. Replicated crossover design is a standard bioequivalence criteria. Using the two-way crossover design does not give an estimate of the within subject viability by giving the same drug products twice to the same subject. The replicate design provides a measure of the within subject variability. Replication design study may be used for highly variable drugs and for narrow therapeutic index drugs. In case of high variability, the drug percentage is greater than the 30, and a large number of the subjects, more than 80, would be needed to demonstrate the bioequivalence using the standard two-way crossover design. Drugs with high within subject variations generally have a wide therapeutic window, and despite high variability, these products have been demonstrated to be both safe and effective. Replicate designs for highly variable drugs products requires smaller number of the subjects and therefore don't unnecessarily expose a large number of the healthy subjects to the drug. With this large number of the subjects is not needed for assurance of the bioequivalence. Replicate crossover design are used for the demonstration of individual bioequivalence, to estimate within subject variations for both the test and the reference drug products, and to provide the estimate of the subject by formulating increased variation. A 4-period, 2-sequence, 2-formulation design is shown below. In the replicate design means we have a large number of the variations in the within subject. We will use the replicate design. Okay, another is narrow therapeutic index drugs. The definition of the narrow therapeutic drugs, also referred to as the critical dose drugs, are drugs in which small change in the dose or concentration may lead to the serious therapeutic failure or serious adverse drug reactions. Narrow therapeutic drug consideration display the following characteristics. Subsequent concentration may lead to the serious therapeutic failure. So there is a little separation between the therapeutic toxic dose and the associated with the plasma concentration. They are subject to the therapeutic monitoring based on the pharmacokinetic and pharmacodynamic. They possess low to moderate within subject variability, and clinical practice does not, doses are generally adjusted to very small increase. The FDA currently recommends the bioequivalence studies of narrow therapeutic index should imply on four-way fully replicated crossover design. The replicated study design permits comparison of the both test and the reference products and reference within subject variables. An individual test recommended in the bioequivalence studies of the genetic narrow therapeutic index drug is test for within subject variability. The test determines whether within the subject variability of the narrow therapeutic index drugs not differ significantly from the reference to the evaluation of the ratio within the subject standard. The FDA currently recommends that all the bioequivalence studies on narrow therapeutic index drugs must pass both the reference scaled approaches, and unscaled average bioequivalence limit should be 80 to 125 degree centigrade. So these are about the crossover study, and crossover studies may be replicated or not replicated. In case of replicated, especially in case of narrow therapeutic index, we will have to use the replicated crossover study, because we will give the same drug two or more than two times to the volunteers to evaluate the exact parameters for the exact variations within the subject, and also to calculate the exact variation between the periods and the sequences. Another study is parallel study design. Remember, there are the two major areas of the study designing. One is the crossover designing and other is the parallel. In case of parallel, we will not use any type of the weight, any type of the washout period. The drugs having the long half-life will be favorable for the parallel design. Number of individuals required for the parallel design is more as compared to the crossover design. So parallel design is a non-replicate. Parallel design is used to drug products that contains drug that have a long elimination half-life, or drug products such as depot injections in which the drug is slowly released over weeks or the months. So in this design, two separate groups of the volunteers are used. One group will give the test product and the other will give the reference product. Remember, there is no any type of the replication, there is no any type of the change of the volunteers from brand A to brand B, and there is no any weight of the washout period, and only we will have to make two groups. One group will be treated with the brand A, which may be test or the reference, and the other may be treated with the B, that may be test or the references. Okay, the one group will be given the test products and the other group will be given the reference product. It is important to balance the demographic of the both groups of the volunteers. Remember, in the case of especially parallel design, there are some drawbacks. One drawback is we should have to check the balance of the volunteers. Means we have to make a set criteria of the some demographic data of the volunteers. For example, their weight, their pathophysiological conditions should be within the range, within the similar conditions. But in case of crossover design, because we have checked the within subject variations, we have applied the same drug on the both of the reference and the test brands on the same individuals. So there are the very little chance to get the minimum, to get any type of the variation. Okay, blood samples of the collection time should be adequate to ensure the completion of the gastrointestinal transit time, approximately 2 to 3 days of the drug product, and absorption of drug substances. It means number of samples which we have to take in the case of parallel design is more as compared to the crossover design, because crossover design are dealing with those drugs which have the less and small half-life, but in the case of parallel design are dealing with those drugs which have the large half-life. So having the high half-life, large time period for the elimination of half of the drug, we will assume that there should be a number of samples will be increased, and the time period for the sampling time will be increased even 2 to 3 days of the drug product, and absorption of the drug substances Cmax and the and suitably increase AUC generally to 72 hours after the dose administration can be used to characterize peak and total drug exposure. For drugs that demonstrate low intra-subject variability is distributed and clearance, and AUC at 72 hours can be used to place the AUC 0 to T and 0 to infinity. The design is not recommended for those drugs that have high intra-subject variations, variability in distribution and clearance. Remember, if we find any type of the intra-subject variations, then we will not use this type of the design, especially the parallel design. So these are the basic concept of the designing of the crossover and parallel. But crossover may be replicated crossover, and in case of parallel, these parallel maybe we are using the ones, and individuals have the equal chance or the 50% chance to get the reference or the test brand. These are all about the single dose therapy, single dose bioequivalence studies. In case of multiple dose and a steady state study design, we will have to make some changes, some different concepts. In next class, we will study the reference multiple dosing steady states. Thank you very much for this, and I hope you understand this point, and if you have any questions, then you may ask me in the end of the videos. Thank you.